Okay, we're going to have to talk about mining for a while. Subject near and dear to my heart since I grew up in the coal patch in the Appalachians. So it's amazing how much you learn on this body that you can apply later. Okay, so what is the real issue in mining? Why are we even interested in water treatment and mining? It all comes back down to corporate mining sustainability. That's the end-all issue for why you even want to look at water treatment and mining operations. We've got issues with operating environments. Most of the time, most mining operations, with the possible exception of coal mining, tends to be in very arid areas, very water-stressed conditions. It's not across the board. We see a lot of coal mining operations in fairly lush areas. Is that working? One of the other issues, of course, is water balance philosophies. Are we doing a positive mine? Or are we doing a negative mine for water discharge? Positive discharge mines, normally coal mining is almost always positive discharge mining operation. It's very difficult to do that any other way. Most metals mines, metal processing areas, are easier to change over to negative operations, which are basically source and conserve. Okay. Climate change has a lot to do with it. Public awareness, where it impacts your financing, is a big issue. Okay. And of course, a more stringent regulatory environment. When we go down to Peru, Chile, and we're dealing with copper mines down there and gold mines, they've managed to achieve some of these things politically because they are encouraging the mining operations to pick up infrastructure costs through tax breaks. I don't know if they do that here or not. Anything like that. What they will actually do is the mines will build roads, water systems, community centers, whatever's necessary for the surrounding area, including putting in dams and reservoir systems because they get tax break to it. Okay, it's pretty generous and it works out very well. Now, one of the other issues we've seen, we started to get involved in water treatment with mining, is that the structure tends to be very fragmented. So when you're dealing with multinationals, they have a very precise corporate perspective, but all the buying's done on a local level, and all the responsibilities on a local level for compliance. All right. So a lot of times you'll have organizations that deal with small parts of the mining operation very well and are very local. Okay, but can't look at the mill or the mine more gestaldically. So what this is here is just kind of representative gestaldically of what a mining operation looks like. Now, every type of mining operation out there, whether it's gold mining, copper mining, coal, uranium, rhodium, whatever it is, those operations are all very specific to the area they're in. Okay, there's almost no commonality across the board other than certain types of processing and the ore processing side. So where we see our applications oftentimes is these areas that are here in green. Okay, and specific areas we want to talk about for right now are areas in the mining operation that we can do that a lot of people can't do quite as efficiently. Okay, so any of these areas you see here in green are areas where Xylem is involved, but the areas we really want to talk about today have to do with the potable water supply and domestic wastewater supply and how you reuse those. And then we get down here, of course, mine dewatering. Everybody's familiar with Xylem from mine dewatering because of flight engulfment, of course. If you're not, we're going to fire us a couple pump sales guys. but they're out doing their job. Okay, and down here in the tailings discharge area, one of the areas we get involved in quite heavily is in gold mining operations, where we actually use ozone for cyanide destruction. Now that seems to be of a lot of interest every time I start talking about that in a conference. There's a lot of people like that subject because, and we found this also applies to other types of mineral processing, where the manufacturing or the processing scope itself creates cyanide in the flume stacks, and in the process of washing out through wet scrubbers, creates a cyanide sludge in the system that has to be dealt with and removed. Using ozone for cyanide removal eliminates the formation of a sludge with cyanide in it. All right, so you don't have as much problem with sludge disposal. Okay, and also takes it out of your water supply and scavenges some other minerals oftentimes in the process. Right, but these are areas we get involved in. And so if you want to talk about how do I take my domestic wastewater from my campsite that happens to be right next to my processing mill and turn it in, can I turn that into demineralized water I can use in my boilers? Can I take that into processed water that I can use for cell wash and stripping machines? Yeah, yeah, you can do all that, no problem. Can I reduce some of this water from the tailing and take it back through a high density sludge process, and can I do something with the water that comes off of that? Most times, yes. Sometimes we can't. You know, sometimes it's just nothing within our scope. But if you have a high density sludge process and you're not returning all that water back to the mine for process, and you want to take some of that off and do something with it, besides running back into the mine for cooling machinery, we can probably do something with it. Okay, so a lot of people don't like to address this. Okay, so we're going to talk about this in a little bit. There are 4 basic phases of mining operations, and every one of these operations has a different need. Okay, exploration, of course, is your first one, and you need some kind of temporary services and supply, and you need to be able to discharge and treat excess drilling water, and you need to be careful of your impact on the environment, but you're small scale here. You know, exploration, what do you got? Half a dozen guys, maybe a 10-man crew at best, you know? Now, back in the day, we took exploration crews out. We didn't worry about wastewater treatment. We just dug a hole. And they don't let you do that anymore. And they got to have something. If you're tying your exploration in with development, you're going to be there for a while. So you need some kind of portable facility for wastewater. 9 times out of 10, you've got to have some type of facility, trailer mounted, for your processed water and your domestic camp water. And it's got to be able to deal with a wide variety of inflows. Now, what we've seen a lot of times now, particularly in arid areas, is this obviously is this a piece of Australia here, is that we'll get a request for, well, yes, we have fresh water in the area, but we don't want to impact the fresh water usage because we're using that for agriculture for the local community, and the local community wants that water. But 50 kilometers away, we've got a saline borehole supply, and that's what we're going to use. Okay. Can you treat that? Yeah, that's easy, actually. That's easy. UFRO, no problem. Saline water is up to about 30,000 ppm. Not a big issue. So if you're going to use saline supplies, that's fine. If you've got contaminated river water supplies, that's fine. If you got supplies of water, groundwater supplies with arsenic, high mineral content, iron, manganese, that's fine. Because more and more mining operations are going to limited impact operations for their processed water. They're willing to pipe the water to do it, and they're willing to treat the water and provide something back to the local community. Okay? That's the kind of area we're working in. So, when you get into development, you're looking at things like dust suppression, you're looking at things like stormwater management, you're looking at wastewater disposal, and you're looking at impact on local resources and water uses. Now, dust suppression, you say, well, where do you get involved in treatment and dust suppression? Mostly that's polymer based. And I saw some really good discussions last week, or actually the week before, on dust suppression and how you apply the water on the road, and I learned all kind of things I didn't know. But we also found out that to provide that adequate crusting on the roadways that you want to get during dust suppression and your polymer feed, you need a water supply that's fairly free of microbial activity. Okay, application frozen. We're seeing mining operations now where you cannot take a vehicle off the site without washing it down. Okay, again, use ozone for wash down. So, and of course, when you move into production and shipping, that's when your systems are really cranked up, and that's where you need larger wastewater systems. So you take your modular systems that you had for your development phase, and you just add modules, okay? The key here is, can you depend on the local company to service all this if you don't want to do it? You know, if you want your people oriented towards production, can you depend on local companies to do it? And that's real key. If you're going to have a small ozone system on the site, or if you're doing arsenic reduction, if you're doing cyanide reduction, where you need about, would you figure about 3 kg to a kilogram? You need about 3 kg of ozone to a kilogram of arsenic to reduce it. You know, can you have somebody that's going to go up and run your service checks and do your maintenance and things in your ozone system? And the answer to that is yes. Xylem already does that with dewatering systems and pumping systems. Okay. And in fact, most underground operations in Peru today, Xylem's got guys living in the camp on 2 and 3 year contracts doing nothing but that. Okay, maintaining transport systems. Okay. Now, here's the question I got asked about today. Rehabilitation and closure. Now, when I was a kid growing up in a coal patch, we had 2 creeks ran through the bottomland, and basically they were generated by mine drainage from 2 different operations, and of course we called one of them Yellow Creek and one of them Red Creek. We didn't know any better. Okay. What do you do with remediation? What do you do with closure? Is that a big issue here? People talking about that all the time? Okay. Kind of an issue for us too. We can't always handle it. We'll tell you right away if we can or not. But it depends on what the mine's closure strategy is. Now, there's a couple of ways of doing this. One is doing a very, very close check of all sources of the supply, instead of just doing point source, like we were talking about for wastewater. You know, we're starting to dig a little deeper in how you determine where your problem's coming from. Okay, so we don't do that, but there are companies out there that do. And a lot of times your natural resources commission, if they're heavily involved in the mining side of the business, they'll be able to perform some of those functions for you. You basically back up through your watershed. You walk the stream. You find out where your pollutant sources are, and you shut them down from there, rather than trying to deal with it all as one major stream. There's a number of ways you can do that. You can close off the source. If you're running tunnels, for instance, running shafts, well, invariably, you solve the problem at that point, but you'll back it up somewhere else. Okay, and it'll show up on the other side of the ridge, or it'll show up in some other watershed area. All right, so you got to be careful about that. But if the answer to the problem involves certain types of membrane filtration, if the solution to the problem involves use of things like ozone, more so than chemical treatment. Okay. If the solution involves, you won't see biological treatment, but things like pH adjustment, that kind of thing, we can help you with that. All right. But our recommendation is do point source. Don't try to treat your whole stream. It requires partnership here. You got to be willing talk to us about what the problem is, what you're trying to do, and what the real water quality that we're dealing with is, and what you want to have out the back end, okay? Because a lot of times, you've got active operations in the same area, you can take that water and reuse it. Reuse is an economical concern. So, we've got container-mounted rigs, desal rigs. Oh, I got a question about different types of wastewater treatment for campsites. Well, there's several. What you're seeing here is known as the submerged aerated filter system. Okay? So generally speaking, when we're talking mine supplies, we're talking either submerged aeration filters or MBR processes. Occasionally, you're looking at SBR, sequencing batch reactors. Occasionally. Why don't you look at that all the time? Because they're pretty good size and they're expensive to do. They don't have a very compact footprint. Right? That, for instance, is an SBR system in that picture. But most importantly, what you're looking for is what's the quality of water that you require from these domestic wastewater systems. And these domestic wastewater systems get used for mining, they get used for food and beverage, they get used for biological plants, pulp, paper. You know, any place where you see that kind of biological processing taking place, you can use these small plants. Okay, so if this is the water quality that you're looking for, we can use this type of supply. If the type of water quality you're looking for is much more than that, okay, this is MBR, that's what we're looking for. If you're trying to get down to like log 4 removals of biological contaminants, coliforms, crypto, you know, this is, when you start looking at this water quality, what you're saying is, I want to bring this water back and reuse it, and I don't care if I have human contact with it. This is near potable supply. If you just want to discharge for irrigation or you just want to discharge for receiving stream, you can go this route. Is this more expensive than that? Yeah. Not orders of magnitude more expensive, but yeah, you're going to pay a little more for it. And this is an MBR type system, this MBR option. As you can see, it's got a very small footprint. Okay. So, if I'm doing domestic recovery of water from a campsite or a mining operation, I need to make that decision about what I want to do with the effluent water. Okay. And again, we can help you with that. Cyanide destruct, kind of touched on it, but that's what that system looks like. Very much similar to what Brendan was talking about. In fact, he gets awful shy and shuffles his feet about it, but he's probably one of the best experts in the company with this type of application of mining, and he's right here in South Africa. Okay? We borrow them and send them around every once in a while. Economic against complexing technologies. When we talk about complexing technologies, we're talking things like hydrogen peroxide for cyanide reduction. We're talking about producing thiocyanates. We're talking about any type of process, even oxidizing process, that leaves a residual in the system. Ozone is a high capital cost. You got to think about it. But life cycle cost on this, payback on an ozone system is 18 months, 24 months for this type of application. Less than 2 years. Okay? So who's got cyanide issues? No gold miners here? Okay. Heat bleaching, vat bleaching, either one. All right, you can use it for reduction. We also have another division that's actually developed an inline cyanide monitor. So now you can data log while you're streaming, your cyanide stream, the rest of your waste stream coming off your acid mine. Anything coming off tailings or going to tailings, you can monitor now. we've got that capability. Okay. And here's an easy one. Interestingly enough, with flight, Xylem has a complete line of mixers. You say, well, why do I care about mixers? Well, if you're running coal mine operation, whoops. If you're running coal mining operation, for instance, where you got classifiers, high water usage, you got to keep the sumps moving without a lot of buildup. We do that. Mixer and pump operations. If you need something that floats out over your tailing pond, keep sludge in movement so you can dredge that pond without having to go and dredge it physically on a regular basis. We can do that. Okay. So anything that has to do with transporting the mining operation itself, including mixing and slurry movement, we can help you with that. There's a lot of opportunity there. A lot of cost savings for your operation as far as shutdown and maintenance time is concerned. Effluent reuse requirements, I'm just going to kind of add this on. Then we can always go back and talk about biological if you want. This is what's going on in the industry today. Control metals and salts in the effluent. Is the membrane a filtration option for removal of polyvalent? Yeah, it is. You can remove metals with it. Typically removed by precipitation ion exchange. Ozone plus membranes is an option. Membranes themselves, depending on what the ion is an option. Because remember, when we talk about membranes, is that's a physical process. That's all it is. So if you got a molecule that's bigger than the pore size of the membrane, and you're not going to scale the membrane with it, you can remove it. Get it out of the system. Removal options depend on particular reuse applications. That's all we've been talking about. Okay, so what are we really talking about when we get talking about mine drains? We've got elevated salt contents. That's one of the reasons you can use membranes. But remember, you got a high capitalization. Right? Moving membranes. But what's the downside to using membranes for salt removal? Is that you create a hypersaline stream that now you got to do something with it. Okay, so keep that one in mind. You solve a problem, but you create a problem. And about the only real good means for dealing with that is through some kind of thermal process. Dry it out. Okay. Then you have to get rid of it. Okay. Usually you have high mineral content and high sulfate levels. Usually pH is pretty acidic. That's why high density sludge process is so popular, because you can remove a lot of contaminants in an AMD, an acid mine drain strain, and still return that water from process use without doing anything else with it. About a process where you don't have to reduce your salt levels, you don't have to reduce your salinity very much. Okay. Oh yeah, and scale formers that interfere with reuse. Now this gets real interesting. Okay. One of the projects we're looking at right now, we're starting to look at, and haven't got very far with it, just came up here in the last week or so, is I've got a company in the US called me up and said, we're pulling mine drainage on remediation. We're pulling drainage from mines we closed. He said, we're doing some pretreatment on it. We're running a pipeline to the Ohio River, which is probably, you're talking about 300 or 400 miles total from their site. And oh, by the way, we're running this right across the Marcellus Shale, which means that we're running right through Arco's fracking operation. And we want to sell them water out of this pipeline so we get some revenue back. And then they talk about what they need to reduce. Sulfate actually turns out to be what they need to reduce, which which unfortunately is not an easy thing to do. But this gives you an idea of what you can do. Okay? Remember, when we talk about recovery of water or reuse, sometimes that reuse means how do I clean this problem up so I can turn it into a revenue stream. Right? If I was a miner, I'd sure want to sell what I got to get rid of. If I could possibly find a use for it. Okay, so discharge limits comparison. What's going on out there in the world right now? Okay, this is the latest that I have. I'm not sure what the overall South African limitations are for discharge. It looks something like this. For the most part, there's a couple South African. Copper, zinc, these are the most stringent international requirements. Iron. What was arsenic here? What was our arsenic number? I'm sorry, cyanide, yeah, cyanide was 0.5. Okay. But, like it says down here, that's only part of the story. Yeah? If you want to reuse the water, sell the water, oftentimes just discharge the water, depending on sensitivity of the receiving stream, you got to take out carbonate, sulfates, silicas, phosphates, and then you also have discharge. Okay. So, the point of all this discussion is, every one of these streams is unique. Can we talk to you about them? Yes, we can. Can we deal with every one of them? No, we can't. All right, got some pretty specific areas. But we will discuss any stream that you want to talk about. If we can't solve it, and we know somebody that can, we'll refer you. Happy to do that. Okay. All right? Questions, comments? Was there any insight here? Is this stuff you already knew? Anything new? Yeah, I think we've got a good opportunity to combine process. Yeah. Get a solution. Yeah, I guess in the end, all of this is really the message we want to get across. Do I have any time to talk about biological at all? I don't. A little bit? Okay, wait back on a little bit. Okay, so the area we did, we talked about this as far as application is concerned, but talking a little bit about mixing and aeration. Some of these processes are fairly unique, and some are based strictly around energy savings. Okay, so whether you're talking municipal, whether you're talking biological effluent streams from industrial process, when I say industrial process, I'm really talking about things like food and beverage. I'm really talking about effluent streams from camps and also effluent streams off of oil and gas refining operations, which tend to be fairly large. One of the things that, Brendan's got 1,000 subjects he can talk about with ozone. One of them happens to be phenol removal in oil and gas. How big is the oil and gas industry here? Oh yeah, okay. I know you do some drilling, but I didn't know that you were refining or not. But anyway, think about this stuff industrially, municipally. What you're looking at, particularly in secondary processes, aeration processes, how do I reduce my energy? Because when you talk municipal wastewater, for instance, you're talking about probably 65% of the energy usage in your plant has to do with aeration. Has to do with the biological process itself. Okay, this is whether you're talking return activated sludge. This is whether you're talking about conventional plant. This is I had some discussions this morning with a couple of guys about How do we optimize anaerobic digestion? And anaerobic digestion comes up as the white elephant, as you said. It ain't just here. Trust me. There's big issues with anaerobic digestion that have been going on for a long time. And are they easily fixed? Actually, they are. Right? Because the secret behind anaerobic digestion is how well am I mixing the substrate? We can come in and we can set up a mixing schedule for you on your anaerobic digester. Old ones, new ones. We can use mechanical mixing, that's what we do. There's some processes now where they do the mixing outside the digester tank. Have you seen those? See a lot of that in the UK. Why are they doing that in the UK rather than using internal mixers? And I'm kind of off subject here, I apologize, but I need to talk about this since it came up. Anaerobic digestion. The reason the UK is doing they're doing mixing for the anaerobic digester outside of the digester is because they have a government incentive now to drive to composted solids in the digester. So in other words, they're not just running sludge, they're not running municipal sludge, they're taking harder substances, organic substances, and feed them into the digester. Therefore, you can't mix the substrate inside the digester. There's just no possible way to do it. All right, so it uses a lot of pumping operations. We can do that for you as well. All right, but the big discussion here is aeration. How do I get my costs down on aerated systems? So, do you have a variety of types of aeration? Oh, you bet. You can do jet aeration, which we do in lagoons, often in the winery business as an example. You can do coarse bubble. You can do coarse bubble for mixing and movement. Now see, this is an opportunity here. If you've got a channel anywhere where you're moving liquids and you've got a problem with buildup in there, and you can't think of any good way to roll this channel, coarse aerators will do it for you. We can do that, no problem. If you're doing aerobic aeration in a system, that's what you want to use. Fine bubble diffused arrays. Now, do we want to be diffusers or us? Do we want to talk to you about, I need 2,000 diffusers in a box, what do you want for them? I don't want to talk to you about that. I can. What, 20,000 diffusers, I'll probably give you a price, But what we really prefer to do is get involved in the engineering of the design to optimize your cost, okay? This is all about energy savings. If you don't lay these arrays out right, you're going to spend more money on your life cycle than you need to, okay? So we designed for that. Talking about density, energy savings, high density diffusers, that's what these are, they're high density diffusers. So when we do a disc system, we're looking at about 24% of floor coverage. When we do the high density panels, we're looking at about 63% coverage. Okay. What we got to look at is trade-off cost, capitalization plus life cycle. All right. Some applications just doesn't work real well, some it does, we can advise you on it. Here's your off-gas testing, here's your energy savings over fine bubbles. Okay, fine bubbles we use quite a bit. Now here's an example of a secondary system that does not require anaerobic digestion. This is biology in a box. You take out all the pumping and the capitalization. You do all your aeration and clarification in a single tank. You can get an anaerobic operation, an anoxic zone, an aerobic, and you can do nitrification, denitrification if you want. And you can adjust the storm cycle loadings automatically. Now, I've built a few of these actually. Pretty bulletproof. I kind of like them. I've used these, and again, I talk about South America a lot. South America is where I did most of my wastewater work. Africa and Asia is where I did most of my filtration clarification work over the years. Okay. Very simple. You got a pre-react zone. So what this is a continuous SBR. Name's fancy. That's intermittent continuous, or intermittent cycle extended aeration. Just means it runs all the time. You don't have to batch. You can do one tank instead of two if you want. Okay, you got a pre-reaction zone here, which treats the sludge coming in. You do your aeration here, your sludge draw off back here, and you take your, and you decant your water off the top. Now you recall when we were talking about water quality, this gives you a very high water quality in an effluent. Generally speaking, we talk about less than 15 milligram per liter BOD, less than 15 milligram per liter TSS coming off of this. You can reduce your nitrogen down to 1. You know, it's a pretty efficient system. Works in reaction, settles out, decants. You still got water coming in the whole time. You waste out your sludge off the bottom. Does it generate more sludge than the conventional system? Yes, it does. Significantly? Nah, not really. You can, yeah. Yeah, phosphate removal is part of the deal when you go to D9. And all you really do is extend the cycle. So the tank gets a little bigger, not much, and you extend your cycle. These are built around time. Now we talked about ease of operation. What's easier to operate than a system that runs on a clock? Once these are set up, they're just time-based. Don't have to pay a lot of attention to them. What do you have to watch out for? Generation of filamentaceous sludge in the front end if you're not screening very well. Okay, as was pointed out to me this morning, because I was talking about process, inadvertently forgot to talk about screens. Got called up real short on that. Okay, but yeah, obviously you need screening, but you don't need anaerobic digestion here on the sludge if you don't want to. There we go, continuous flows.
What's the maximum CID for that tank?
I'm sorry?
What maximum CID for the system carry?
CID?
CID or BOD?
Oh, BOD coming in. Yeah, I'm sorry. Yeah, you just look at it as BOD coming in. They don't like to tell you this, but you can handle up to about 1,000. Okay, depending on what kind of reduction you want. You're looking for like a 98% reduction. Yeah, it'll handle it. It'll give you that extended cycle to do it. Normally speaking, when they talk about using the ichthys system in process, they talk to you about 500 milligram per liter of COD, but you can run higher, or BOD, you can run higher than that. Yeah. All right, so you can take pretty heavy loadings on these. Like I said, just set the clock for it. That'll run it out. They normally operate over 4-hour cycle times. Okay, just repeat cycle. So the big advantage here is the only time that you aerate is during reaction zone. So it minimizes the amount of time that you've got aeration running. Now if you have multiple tanks, obviously something's going on all the time. Now, can you use these industrially with anaerobic digesters? And the answer to that is yes, you can. In fact, we use this type of SBR, this continuous SBR system, in processes for fruit and vegetable processing, which always has some kind of anaerobic digestion involved. We've even worked with a couple people like Veolia, and they're licensed for pack systems to provide anaerobic digestion. Put 4 or 5 of those in Chile like that. Okay, they use a secondary operation, but they use a round tank instead of a rectangular tank for no other reason than preference. Quite honestly, that's just the way they like to build. Okay, so industrial applications, food and beverage, fruit and vegetable process, dairy, any type of application like that that requires secondary process, either with or without anaerobic, you can look at it. Okay. Like I said, it's very simple. Now, when you go to do denitrification, of course, since you got an anoxic operation in the process, you put a mixer in. Okay. So everything in this tank, including the control system, we can provide. More importantly, provide it and guarantee the process system. Now, that's one thing you always want to do. I don't care what your vendor is. When I was running projects, I always look for vendors and suppliers that would give me a partial process guarantee. I wanted to make sure that each piece of my line, when I was putting a deal together for a client, had a guarantee on it. Not only had a guarantee on the process, but had a guarantee on my critical path and my delivery and execution schedule. Okay. So what else goes with this? Screens up front, grit removal, into the process, UV on the back end, and if legally you call for chlorine residual, chlorine in a contact tank after UV. And if you want to remove nova, if you want to do pathogen reduction, tertiary filtration goes on the back end. Now, tertiary filtration can be gravity media filters we talked about, membrane filtration. Depends on your footprint, depends on the amount of money you want to spend on the process, depends on what your life cycle costs are, what you're looking at, what kind of alternatives you want to see. Okay. You give me your waste stream, you tell me what you want and why you want it, because sometimes the two aren't the same. We'll try to work in the system. If I can't do it, I'll tell you right away. Okay. Within 7 days after you present me with a problem, I'll tell you whether we can do it or not. And we'll put it together. But we will talk to you during the process. Well, I want to sit down across the desk from you and talk about it. I have literally walked out of meetings where I've had a potential client stand there and say to me, well, I don't want to really tell you, but it's roughly this, but I don't want to tell you what I'm going to use it for, and I don't want to tell you what my really effluent quality is. You give me some alternatives, and I'll take a look at picking one. I don't feel the love, you know, in a situation like that. I'm one of those guys like a partner, okay? So, but anyway, that's that opportunity. Another thing is biolube oxidation ditch. Like I said, I don't see a lot of these down here. You were saying that they're, oh, they are? Okay. We can do retrofit on existing loops. We can also take loops and put membranes in. Want to do that. That's kind of cute. That works pretty well. Works better in rectangular tanks. But we can take existing civil works and go from standard processes, conventional processes, to membrane processes within the civil one. That's a big cost saving. Okay. But yeah, we can do loops, and we can combine mixing and aeration. And there's obviously advantages to having mixing and aeration taking place in the loop. You minimize your energy loss by placement, and we run CFD on these. So we can work with you on the design. There's a shot of the mixtures with the aeration, so you can clearly see your anoxic and aerobic zones. Okay. This is a case study. This was the original plant data. Initial situation for mixture plus aeration. They had a lot of thrust losses. This is the update. Power consumption dropped from 42 kilowatt to 21. Okay. With an increase in water velocity. Bubble retention time picked up. And of course, if you got retention time, you got improved oxygen transfer. Okay. And again, let's bear in mind, this is not exotic technology here. This is nice, clean hydraulic stuff. You sit down, you figure it out, figure out where to experience knows where to put the mixers versus the aeration. Figure out what your energy recovery needs to be, what your consumption savings need to be, and you can work it out. Not hard, okay? Just need the background, just need experience. The advanced process control solution, and this is just basically the operating and monitoring, data logging process. Basically what we're saying here is yes, we can supply you with a control system, with data logging and report generation. A couple of screens. Support the operator. Mentor the operator. It's the whole purpose behind this. And you put out your monthly report. Okay. Membranes and wastewater. Man, we already covered most of this, right? MBR plus RO. I mean, what do you want to do? These are for wastewater. We talked about water treatment. There were two basic designs for water treatment. Just like there are basically two basic designs for MBR applications for wastewater. Always you're going to have your screen up here. Always you're going to have your pump station. You're going to have some kind of sand removal, grit removal, compact systems. You know, we just buy those out. A lot of good suppliers for those. Generally, you're going to sometimes need equalization tanks, sometimes you don't, depending on the design. Fine screens up here, and then this goes into your denitrification, nitrification with your aeration. Goes to UF. You bring sludge back around, water back around to the plant. Why do you do that? You do that to increase your mixed liquor suspended solids, your MLSS. You want to bump that up about 20 to 25% higher than normal. So you've optimized the operation of your membrane. Reduces your sludge loading, gives you a higher mixed liquor, higher level mixed liquor, you bring it back into the system, and gives you a much more efficient operation because you're running membrane, so you can run a higher loading rate, which gives you a more compact footprint. Yeah? So you want to run 12,000, 18,000, something like that. Okay. Good way to go. Nice way to go. And then you're coming out here, this RO gives you a tertiary treatment along with the ozone and UV. And the UF system can be pressurized or submerged. Why is that a big deal? Footprint. That's all. Use a little more room with submerged. Different type of membrane. Okay. Down here is the other process. As you can see, pretty much identical coming up to here. Okay, only here you're dealing with a more conventional alignment, and then you go to your membrane feed and coagulation coming off your secondary, and then you go to UF, and then you go to permeate tank, which feeds into your RO, which goes out again. So it all depends what you want to do. This is tertiary with RO. This is straight MBR with RO. How complex do you want to get? What's your application? Those two basic designs. What's your change from your conventional activated sludge? We had a big conversation about activated sludge off to the side here earlier. You take out the primary clarifier. All right, let me back up there a second. Here's your standard activated sludge system. The only thing it's not showing here is your sludge return. Okay. This is without talking. This is taking out the anaerobic digester. Okay. Primary clarifier, denitrification, nitrification, secondary treatment, secondary clarifier, sludge return back to primary. Okay. First thing you do is take the primary clarifier out of the solution. That becomes your biology, denitrification, nitrification, much smaller footprint. Take the secondary clarifier out, replace it with a membrane filter. Now you've got secondary and tertiary treatment. Remember, because it's multiple barrier, you get your biology taking place here, and your physical reduction taking place here, the membrane. increased MLSS concentrations, and you just close it up. That's what I'm saying. You can put membrane solutions in any civil structure that you got to build. Okay. Why? Direct reuse, okay, pre-treatment. Takes care of all your stringent discharge limitations if you got them. Okay. Absolute membrane barrier, so no matter what the loading is, now you might have to backwash more frequently on your membranes, but regardless of changes in your influent quality, you will always get the same thing out the back end. You will always get the same effluent quality because you got a mechanical barrier. All right. But like I said, it gets a little more costly. You got to clean that thing quite a bit more often. But it's an automated process. Will take care of itself. Compact footprint, and you minimize costs, and you work out what your asset recovery is on retrofit. Okay. Great for expansion. I'm done, right? 2 o'clock, I'm done. Questions, comments? If you think of something later, get hold of these guys. Yes, sir.
Do you do the process design
Yes, sir.
back in integration at your end, and then that will come through to this?
To civil, yeah. Yeah, we don't do civil work. We don't do yard piping. We do very strict battery limit. But we'll do the process design. Okay, so oftentimes what we'll do is we'll team up with a local EPC or contractor.
That could be arranged on the thing, the process design and solution.
Yeah, we'll do the process design, provide the solution, guarantee the process. How you install it, how you set it up, somebody else's issue. Yeah, I don't have that. I don't have the project management staff so I used to have for that kind of thing. All right, what else to do? Any other questions? Think of anything? You got these guys, you know their email addresses. Come see me, get a card. I don't mind jumping in.